Hi, in this video we're going to look at something called a non-local scope. Now we've already seen local scopes and global scopes as well as the built-in scope, but a local scope and a non-local scope are related, but they're a little bit different. And this is when we start defining functions within another function, and we can certainly do that. Let's take a look at an example. We may define an outer function in our module that has some code, and then at some point it defines another function. You can definitely do that. You can define a function inside another function, and then maybe you execute that function within the outer function. So this is an example of a nested function or an inner function. So when we call out a func, what happens? Let's take a look at the scopes and the namespaces that we have. Well, obviously we're sitting in the module, so we have a global scope. Then we have the outer func. Well, outer func has its scope, right? It has a local scope. We've seen that before. However, we now are defining inner func as well from inside outer func. So now there is another scope that's nested inside the local scope of outer func. They're both local scopes to functions, outer func and inner func respectively. But they're local scopes nested within each other, nested within the global scope. And so Python will start looking for variable names from from wherever you are and moving its way outwards. But there's a difference between local scopes and the global scope. There's kind of a boundary between them and we'll see some examples of that. But if you have a variable defined in here that doesn't exist in here, Python will look in the outer scope for it, right? And in some cases, it will continue over to the global scope. In other cases that we'll see later, it doesn't. It will stop at that boundary, and we'll come back to that. So both the functions have access to the global and the built-in scope, right? So inner func has access to the global scope and the built-in scope, and it also has access to its local scope. Outer func, same thing. It can access its local scope, the global scope, and the built-in scope, just as before. But the inner function now also has access to the enclosing scope, which is the scope, in this case, of outer func. So that scope is neither local, right? It's not local to inner func. It's not global either. It is called a non-local scope. And these non-local scopes are nested within each other. So let's see how things work with non-local nested scopes. So let's take a look at this example that we've seen before, just to remind you. Let's say we have a module, we have a global variable a equals 10, and we have this outer function that just prints a out, and we call the outer function. Well, when we call outer func, Python sees the reference to a. A doesn't exist in the local scope, so it looks upwards. And in this case, we're sitting inside the global scope, so it's going to find the global variable a, the module variable a. And so that's the one it's going to use. Now consider this example, where we have this outer function that defines a variable a equals 10. Now that variable is going to be local to outer func. Then we define inner func inside, and we say print a. Then we're going to call inner func, and then we're going to call outer func. But what happens when we call outer func? Well, inner func is created and then called. Where does this a come from? Well, a is not in the local scope of inner func because it was referenced but not assigned a value. So it is not local to inner func. So Python says, okay, I've got to go look for it. And it's going to start looking in the enclosing scopes. In this case, it's first going to look at outer func's scope, right? So it looks for it in there and finds it. So it's going to use that one. It's going to say, okay, I got it. If it didn't find it there, it would go and look in the global, right, scope. So let's take a look at another example. Let's say that we have a equals 10, which is global, right? And then we have the same thing as before, except now our a is at the global level, and we haven't actually assigned it a value in outer func. So a, by the time we reached inner func, is not local to inner func. It's not local to outer func either, right? And so it has to go look for it in the enclosing scope, which in this case is going to be the global space, right? So this here references the global variable. Before, we stopped at the outer func because Python reached it first. So it's whichever one it reaches first. Now let's see how we can modify global variables. Well, we've seen that before. We use the global keyword, right? So again, this is an example we've seen before. We have a is 10, global variable, and inside out-of-func we say a is global, and then when we modify a, we're actually going to modify the global variable a. So after we called out-of-func1, when we print a, well, it's now 1000. The global variable a has been changed to 1000. We've seen that before. But we can do the same thing from within a nested function as well. It doesn't matter where you are in the code. So let's say we have out-of-func2 now, and it defines a function within it called inner-func. And inner-func defines a to be global and then modifies a. And then out-of-func2 then, after it's defined inner-func, calls it, which means that this piece of code, a equals hello, is going to get executed. So when we call out-of-func2, what happens? Well, it's going to go ahead and call inner-func. Inner-func is going to define a to be hello, but the global a, right? So it's going to point the global variable a to this new object called hello. So after out-of-func has finished running, when we print a out, it will print hello. It's modified the global variable. So it's okay to use a global keyword in inner functions as well. Python is going to go straight to the global namespace and point our variable to that one. Okay, so what about modifying non-local variables? So in other words, variables that are not global, but that are not local either, like we saw with those nested functions. So let's say we do the following code first. So we have our outer function, and x is equal to hello. What does that mean? Well, that means that x is a local variable to out-of-func, okay? And then inner-func, well, inner-func, x equals Python. Well, Python sees this and says it's an assignment. It's a local variable. So x is now local to inner-func. This x here masks the x in out-of-func. And then we call inner-func, and then we're going to print x. So now when we call out-of-func, it's going to print hello. Why? Well, remember, when we call out-of-func, x is set to be hello. We define inner-func and call it. It sets x to Python, but that has nothing to do with the x in out-of-func. So when inner-func has finished running, x is still the same one as before, and hence we get hello. Okay, so this just explains what I just said. And so we say that this x here masks the x in its enclosing scope. Now, we can, however, modify non-local variables, and we just have to explicitly tell Python about it. Just like we did with the global keyword, there is a keyword we can use to tell Python, hey, this variable here is a non-local variable, and it will look in the non-local nested scopes. It will not, however, look in the global scope, right? So we do that using the non-local keyword. Let's see an example. Let's do def out-of-func again, x equals hello. Now we define this inner function, and we declare x to be non-local, and then we assign it a value. Well, this x here is now the x in out-of-func, because we said it's non-local, and this is the first one that it finds, moving upwards in the chain. So when we call inner-func, it actually modifies the value of x to Python in out-of-func, right, in that scope. So when we print it, we're going to get Python, right? So let's take a look at this. So whenever Python is told that a variable is non-local, and this is really critical, it will look for it in the enclosing local scope chain until it first encounters the specified variable name. But it will only look in the local scopes. If you have a variable that is only in the global scope, and then you somewhere in a function say non-local that variable name, you will get an error, because Python will say, hey, I couldn't find that name in a non-local scope. Yeah, it existed in the global, but if that's the one you meant, use the global keyword. Otherwise, it will restrict itself to just using nested local scopes. So let's look at an example of how this works. So again, we just have the same thing as before, def outer, x equals hello, def inner. Now we have another nested function, def inner2, right, which is defined inside of inner1. So now we have 3 levels of nesting. And here we declare x to be non-local, and then we set x equal to Python. So what x does this refer to, this non-local x? Well, it's going to refer to the one in outer. Inner doesn't have a local x, so it says, well, it's not in there. Let's look one level up, and it finds it in outer. So when we eventually print x from outer, it has been modified by the call to inner2, which was itself called by the call to inner1. So let's look at this with a picture instead. So we have our global scope, and inside our global scope we have this scope for the outer function, right? That's a local scope. And then we have a scope for inner1, because inner1 was defined, so it has a scope, and it's going to be inside the outer. It's going to be nested inside the outer scope. And then within that we have inner2. Inner2 was defined inside inner1, so we've got a local scope for inner2 that's nested within inner1. When we run outer, we have x equal to hello. So now we have this local variable x that has a value of hello. That's in the local scope of outer. Then we call inner1. Well, what happens when we call inner1? Oh, and by the way, inner1 is also a label that exists in the scope of outer, right? Because this function inner1 is just a name that points to a function object. So that name is in that scope. And I'm not going to keep repeating that. I'm just going to focus on the x variable. So when we look at inner1, there's only one thing in the scope of inner1, really. It's the inner2 function label, right? That's in there. And then when we have inner2, what do we have? Well, we have x, right? We have x equal to Python. We're setting x equal to Python. However, we said that x is non-local. So that x is really pointing to the x, the first x that it finds in the nested local scopes, which happens to be the one in outer. So when we set x equal to Python, what are we doing? We're changing the x in the outer scope. And so when we print x here in our outer function, right, we're printing x, which happens to be the x in the outer scope, then it's going to print out Python because we modified it from within inner2. But consider this example now. Let's look at this one where we have def outer equals is defined as follows. So x equals hello, local, right? X is local to outer. Then within outer we have inner1. X equals Python. That's an assignment. It is local to inner1. X here masks the x from the outer scope. Then we have def inner2 with non-local x, and we change x to Monty. What does this x refer to, this non-local x? Well, to the first enclosing scope x label that we find, which happens to be the one in inner1, right? So now when we set x equal to Monty, we're actually changing the x from inner1, not the x from outer, right? Because x here is local to inner1, and we'll see a diagram of that. So let's see what it looks like. So we have our global scope, we have our local scope for the outer function, and there's an x in it, right? There's also inner1. I'm not going to keep repeating that, but x is the one we're interested in. So x is there, it has a value of hello. Then we have a scope for inner1. And inner1 has its own x because we have this assignment. So x exists here as well on its own, and it's Python. Then we have inner2. Inner2 is defined nested within inner1, so its scope is going to be nested within the scope of inner1. And now, however, we have an x, but we said it was non-local. So that x points to the very first label that it finds in the enclosing scopes. In this case, it finds it in the scope of inner1. So the x in inner2 points to the x in inner1, but you'll notice that the x in inner1 doesn't point to the x in outer. They're different variables. They're in different scopes. So at the end of the day, when we are going to print, well, we're going to call outer. What is it going to do? Well, it's going to call inner1. When it calls inner1, it's going to set x to Python. It's going to define this function. Then it's going to print x before calling inner2. Well, before calling inner2, x is equal to Python. So it's going to print Python out at this point. Then we call inner2. Now, inner2 changes the value of x to Monty, but which x is it? It's the one in inner1. So now, after inner2 is finished running, when we print the value of x, it's been modified. It's now equal to Monty. So we print Monty out. Now, inner1 has finished running. and we print x from the outer function, right? And now we're in this x over here that's in the outer local scope. That was never modified, so it printed hello. All right. Let's take a look now at this example. So we have, again, this function outer, and x equals hello, local variable to outer. Now we have an inner function within outer, and we declare x to be non-local. So let's see what's happening. So we have our global namespace, our global scope. Then we have the scope for outer, and outer has this variable called x that's currently set to hello. Next, when we're going to call inner1, we're going to have a scope for inner1. What's going to be in that scope? Well, there's an x in there, but x was declared non-local. So yes, there's an x here, but it's actually pointing to the one in the outer function, okay? Because we said it was non-local. Now we also define inner2. Now inner2 also has a non-local x. So the scope for inner2 exists and it has an x in it. But that x says, you got to look for the first enclosing one. And so it's going to look and find this x in inner1, which is itself actually the x in outer, right? So you can think of it as a chain, or you can think of it that it goes directly there, that x doesn't exist in that scope, because technically it doesn't, right? So really the one it's going to find is the one up here. But it may be easier for you to think of it as a chain, right? Even though it technically isn't a chain. So now, when we call outer, what happens? Well, the first thing when we call outer is that it sets x to equal to hello, defines inner1, and it calls inner1. Okay, so let's call inner1. So when we call inner1, we set x equal to Python. But which x is it? It's the one in outer. So technically, this x over here has just changed its value, right, to Python. Then we define this inner2 function, which has a non-local x, and x sets x equal to Monty, but we haven't called it yet. So first, we print the value of x before we've called inner2, right? And what are we going to get when we do that? Well, it's going to be equal to Python, right? That's just what we set it to. Now we call inner2. So at that point, we modify the value of x. Which x? Well, this x that's in inner1, but it's non-local, so it's technically the x in outer, right? So it's going to modify this x over here, which is modifying this x over there. So we've changed it to Monty. So now the value of x is indeed Monty after we've finished running inner2. Then we're done with running inner1. We move on to the next line of code, print. So now we have print outer comma x. Well, which x is it printing? It's printing the x of the outer scope, right? We're in the scope of outer. And what's the value of x at that point? Well, it's Monty, because we just changed it from within inner1 from within inner2, right? So it was nested 2 levels deep. But remember, all these variables are pointing back to the outer scope x. So we are also going to get Monty when we print x out at that level. So hopefully you're starting to get a feel for how these things chain together. So let's look at another example that now involves both non-local and global variables, and let's see how the things kind of mix with each other. So let's say we have a variable x at 100, which is a global variable. In other words, here's our global namespace, and we have a variable called x in it. Then we have this outer function. Now the outer function, therefore, is going to have its scope, and we have this x equals Python in there. What does that mean? That means it's a local variable. It's not the global variable. We have an assignment. We didn't say global x. So x is local to the outer function. Now we have this defined inner function, inner1. And inner1, therefore, is going to have its scope, but it has this non-local x. So it has this variable x that's actually pointing to the outer function, because that's the first one that it finds in the enclosing local scopes. But inside of inner1, we define another function called inner2. So again, we have this nested situation where inner2's local namespace and scope is inside the scope of inner1. And it has an x as well, but you'll notice that I have the keyword here, global. So it has an x, but that x means the global x. So that x is actually pointing to the one in the global namespace. So when we modify x over here, set it equal to hello, we're actually modifying the x in the global namespace. When we modify the x in inner 1, we're actually modifying the x in outer, right? So you can kind of keep your arrows straight, right? Even though they're curved. All right, and then we call inner 1 and then we print the value out. So let's see what happens when we call outer. So now let's execute all that stuff. Well, the first thing it's going to do, it's going to set x equal to Python, and then it's going to define this function, and now it calls the function inner1. Well, the function inner1 changes the value of x in outer to Monty, because it's non-local, and then it defines this function, but doesn't call it yet. And now we print x. Well, what is x right now? Well, we just set it to Monty, right? So that's what it is. Then we call inner2. And we have this global x, and we changed x equal to hello. But we changed the x to hello that's in the global namespace. So now when we print x after inner2 is finished running, we're still left with Monty. That hasn't changed. Now inner1 finishes running. And what happens when we print the x in the outer namespace? Well, remember, the x in the outer namespace is this one here, right? And we modified it to Monty in inner1. And so we also see Monty coming back out of the print statement. Finally, outer finishes running, and now we print x. Which x are we printing now? We're outside. We've finished running outer. We're no longer inside. So which x does this mean? Well, that means the one in the module, the one in the global namespace. And its value was changed by inner2 to hello. So when we print that out, we get hello. Okay? So easiest thing is just to think of, the kind of chains that you have and what's referencing what. The other thing that sometimes you may want to do is not use the same variable names. Okay, that's one way of avoiding some of these problems. But sometimes you actually do want to have a function refer to the non-local scopes variables. And we'll see the reasons for doing that. So now let's switch to some code and let's see how all this works in action. Thanks for watching. I'll see you in a bit.